test the audio quickly, see if everything works correctly or not. Can't hear myself. Do I have the audio? Okay, can hear myself. It's, well, good and not good. It's good because the stream is working. It's not good because I don't like my own voice. So I would normally don't monitor the sound continuously. So we'll get back to Bionic Chaos in a sec. I'll just cover a few random things that might be of interest. So yeah, thank you for all the people who subscribed. I have quite a few stakeholders at the moment. There is quite a lot of videos. This is including live streams as well. If anyone was interested in my YouTube analytics, the only thing I'm actually looking at is watch time hours. So I reached 660 hours, and apparently there's another tool that can show you that. That's in the public domain. I uploaded about 286 hours worth of videos. So the ratio is about 2.3 for what is it, watch hour over uploaded hours. So hopefully that's my new KPI, 2.3. Hopefully I don't go below or significantly below that. So we'll trace that over time, this 2.3 number, see how noisy it is. So close that, don't need this as well. We'll start developing in a sec. We'll still be doing the EEG to music transformation. I'll just touch briefly. Yeah, so supposedly GitHub Co-pilot has this new feature. So they supposedly updated it. It's supposed to be much better now. Now there was a video on their official YouTube channel, and it mentions this workspace thing. So where you hit oh, now it's actually disappeared for me. That's interesting. Now I only have asked about VS Code, whereas before I had this workspace as well, but I kept getting this array buffer allocation failed. So yeah, I was kind of complaining about this in the past. So on one hand, Microsoft people, GitHub people, Copilot people did listen and change this, address this, but for some reason it doesn't work for me. It didn't work in the video for the person presenting. So essentially the idea is that with this workspace command, which disappeared for me, that's quite interesting, that happened live, you're meant to be able to access your entire project, so all the files, which was not possible prior. Yes, this one does work. So if I go to a specific file, might as well start with the go back to the EEG into music. So say we have this Python code. Might as well run it. Music is not going through, is it? Let me check. Why is this sound? Give me a sec. Default. Let's try this again.
This application uses intracranial EEG data from NeuroVista, available at www.ieeg.org. This rich dataset offers a unique opportunity for exploring brain activities in various states.
Right, so this does work. That's the application that we were working for a while in the past. It's meant to be playing all these notes that currently we cannot hear because in the browser we also get this a buffer not found, which is actually surprisingly probably not related, but it's similar to the GitHub Co-pilot a message that I'm getting. The array buffer allocation failed. Actually have to make this window smaller just so we do not load that many nodes, including 10 seconds at a time. Sorry, I had to sneeze. Luckily, I was able to mute the microphone. Someone is asking about the sign language recognition project. So, yeah, I did do it in the past. It didn't work so well. There's actually a Kaggle competition that you should just go and look up. I already mentioned this in a previous stream as well. I might be looking at it as well, but maybe you will, because you're asking, probably be doing a better job. Can ask GPT-4. Yes, if you ask, I don't know if you have access to GPT-4, maybe not. Can you give us a summary about sign language recognition and what was already done on that front, including the Kaggle competition? Maybe include the results from it. Was there any revolutionary breakthrough in the way it works? Yep. Let's see. It's gone for Bing search. Unspoken ASL. Kaggle competitions, blogs at Nvidia. Yeah, Nvidia, there was actually someone who won that competition who actually works for Nvidia. So that's probably why it's looking at that blog.
Sign language recognition technology has experienced significant advancements over time. The journey began in the 1960s with Signing Exact English, a system designed to help non-signers interpret sign language into written English. However, this early system was limited due to its reliance on a single, predetermined set of hand movements. In the 1980s, researchers began developing computer-based sign language recognition systems. These early systems used cameras to record hand motions and pattern recognition algorithms to examine them. However, they had limited accuracy and vocabulary, making them inadequate for every...
Nothing in... Yeah, stop that. Stop this as well. in ChatGPT, I was giving it instructions to certain custom instructions. Yeah, I do have respond as short and succinctly as possible. Seem to be ignoring that. Put an exclamation mark there. Yeah, that name actually sounds familiar. Kristoff Henle. Just read that bit quickly.
Regarding the Kaggle competition for sign language recognition, Kristoff Henle from Nvidia won the top spot in a challenge focused on detecting American Sign Language fingerspell characters and translating them into text. This competition was unique due to its novelty and the relative lack of research in this area compared to other fields like computer vision or speech recognition. Henle's winning solution used an end-to-end model adapted from speech recognition AI, augmented with a training dataset of over 3 million fingerspell characters. This dataset was captured via smartphone videos and converted into coordinates representing the signer's face, hand, and pose. This approach accounted for different styles, dialects, and speeds of fingerspelling, making it a versatile solution for various applications, such as web.
Yeah, for memory they're doing sign, but the problem with that is that they were actually limiting it to a specific frame, so only have hands alone. And another problem is that they're only looking at one hand at a time, because apparently there's a dominant hand and a secondary hand, and sometimes sign language speakers swap hands, so they use primarily one hand and the secondary is like aiding, or sometimes you only have one hand on the screen for spelling out. So there's all these complicated issues that make data collection and cleaning it up quite complicated. So I gave it a go, but yeah, essentially if you look at it, this person's code should be available on GitHub. Should give you a lot of information about how to do it. And yeah, I might try it again. I don't know if it's an end-to-end model including data collection or not. I think the data was pre-collected. Just try last prompt. Was that solution end-to-end in terms of collection data real time from a video footage and translating sign language to text, or was the data pre-recorded? Also, is the code available open source online? Any suggestion how to turn this into a Flask web application? Yep. It's repeating itself. It's ignoring my request for succinct responses. I know.
The winning solution in the Kaggle American Sign Language Recognition Challenge, led by Nvidia and Kristoff Henle, focused on recognizing fingerspelled characters and translating them into text. Their approach involves an end-to-end model adapted from speech recognition AI. They enhanced their training dataset with over 3 million fingerspelled characters using data augmentation, capturing these characters via smartphone videos. The data was then converted into coordinates representing the signer's face, hand, and pose in each video frame. The data used was pre-recorded, not real-time. As for the code's availability, it's not explicitly stated whether it's open source or not. For integrating this technology into a Flask application, one would typically use a pre-trained model to process video input, converting sign language to text, and then implement this functionality within a Flask web framework for user interaction and display.
Alright, if I have the training data set available, I'm pretty sure it's available somewhere. Yeah, we could try giving it another go, but yes, it will. It might be quite a lengthy project. So I don't know, it kind of depends where you are at this stage. Have you done anything at all, because I mean, yeah, so that's the beginning of it. You start with like images like that. Well, then you'll have to kind of either learn sign language. So obviously it will help if you actually know sign language in whichever language. Otherwise, you need to use those pre-trained videos that actually had someone who can understand sign language translated the video footage into text, and then you train a model based on that. That was the competition was. So it's kind of depends where you want to start. Yeah, probably if you're looking at another language, that pre-trained model will not work, 'cause that was done in ASL, American Sign Language. So you will have to essentially train from scratch, depending how different the languages are. Okay, let's get back to this. Start a new Co-pilot as well, and a GPT-4. We have this tag, this code. The problem with it is that I cannot hear any sound. I'm kind of struggling with this one for the last couple of days. Do you think we'll be able to do it in, say, half an hour or something? Probably not. But we'll give it a go anyway. The bottom of the code. To say that I cannot hear, the sound is not being played. The button does work. That's prompts. So I have this main.js that is important. Yes, so the problem is currently now these nodes. There's a problem with them as well. Clear console. Yeah, it's also playing only 2 of the nodes. There should be more of them. Yeah, there's some sort of translation. There's some sort of syntax thing. Let's pop this stuff in, starting from index HTML, then we'll do JavaScript, and then the Python code. to explain Copilot, explain this as well. So I have GitHub Copilot on the left, GPT-4 on the right. Yeah, I did say this code is for reference only, don't generate anything, but it still did, which is okay. So the HTML is not where the problem is. Let's do this as well, Copilot. Explain this. Hopefully it picks up on the prompt at the end of the code. Pop it into GPT-4 as well. Yeah, it's something to do with the nodes not being loaded properly. Yeah, GitHub is giving generic responses, whereas GPT-4 is actually giving more specific, trying to solve the problem. Still generating. Yeah, it's something with the node, the names of those nodes. Essentially have to look at the documentation. Yeah, how do we do that? It's a good question. Essentially this sound font. So this is where the JavaScript is. Yes, it was built just recently. No, wait a sec, that's not the one we're using. Yeah, it's this one here. Doesn't have a there a link in this thing? No. It's like JavaScript where we loading piano. So to understand why do we need to load these nodes manually. So I do need to load them manually. So let's see what other nodes. Yeah, we'll potentially have all of those as well. Let's just load all the nodes. Is it possible to load all the nodes? Yep.
Yes, it is possible to load all notes for an instrument using the SoundFont library, but it is important to consider trade-offs. Memory usage. Loading all notes for an instrument can consume a significant amount of memory. This might not be an issue for modern computers, but it can be problematic for devices with limited resources. Loading time. The more notes you load, the longer it will take for the instrument to be ready. Users might experience a noticeable delay when the page is loading. Network bandwidth. Each node loaded requires a network request fed to the audio file. This can increase data usage and loading times, especially on slower internet connections. If these trade-offs are acceptable for your application, you can modify the load piano function to load a full range of piano notes. Typically, a standard piano ranges from A0 to C8. Here's an example of how you might modify the function to load all notes.
Yeah, we have to try that.
In this updated function, we create an array nodes to load containing all node names from A0 to C8, taking into account the exceptions of the extremes of the piano range. This function then attempts to load all these notes into the piano instrument. Remember to handle the increased loading time and potential memory usage in your application.
Up again. Guess it's actually playing all the test nodes. Let's reduce the window size to 10. just select a different channel just for the heck of it. I think it's already should be playing the notes, but it's still skipping stuff. That's not cool. Let's pop. Okay, this is from the console.
The log entries you provided are from a local web server, commonly a development server, which shows the requests made to it and their responses. Here's a breakdown of what each line in the logs represents. It indicates either an uninitialized variable or a missing value in the request. The scaled_EEG_frequencies in musical_notes lines show the server's processing output, where EEG data frequencies are converted into musical notes. These logs are typical for a web application in development, especially one dealing with dynamic data like EEG readings. The successful status codes, 200, suggest that your server is correctly handling requests. However, the request with channel equals undefined indicates a potential issue in your front-end code where the channel parameter might not be getting set correctly under certain conditions. In the code snippet provided, notes like C#6, F#6, and A#5 feet are indeed included. The loop constructs the full range of notes for each octave, including both natural notes like C, D, E, and sharp notes like C#, F#, A#. To clarify, here's how the loop works for these specific notes. For C#6, when the loop reaches the 6th octave, octave equals 6, it includes C# in the notes to load, creating C#6. For F#6, similarly, in the 6th octave, F# is included, forming F#6. For A#5, when the loop is at the 5th octave, octave equals 5, it includes a hash in the notes to load, resulting in A#5. The loop iterates over a predefined array of node names, that includes both natural and sharp notes for each octave from 0 to 8. This ensures that all variations, including the sharp notes, are accounted for in the range of a standard piano.
Okay, so why am I still getting an error and some of the notes are being skipped? Something to do with the syntax of this thing. Just try these two variations. One will have the basic ones. I suspect all of this one will be played okay. Wait, I have to restart the page. Right, so this 4 playing fine. It's something with the syntax. Yeah, now I suspect only A5 will be played. Right, so all those are being missed. Again, quickly. Yeah, so 3 of them. Do not work. Understand the context.
The error messages you're encountering, such as buffer 85 not found, indicate that the SoundFont player is trying to access audio buffers, samples of musical notes, that haven't been loaded or are not available. This typically happens when the application attempts to play a note for which the corresponding sound sample has not been loaded or is missing.
Well, that's right, they're still missing. Is there conversion happening? Play sequence, convert the EEG to music. Load EEG data, update data. Load piano. Yeah, we need to verify the names. So the problem is these nodes, the one that have sharps, all the sharp nodes, but not work. These nodes will work. So it's a problem with the syntax. A syntax issue.
In this modified function, before attempting to play a note, it checks if window, piano, buffers, note, exists. If the buffer is not found, it logs a warning and skips playing that note. This should prevent the errors you're seeing and provide more insight into which notes are missing.
Okay, is there some sort of syntax problem? Because the following will play okay, and these ones will not play, will give a missing buffer error. The issue, if this note's not playing while this one's play fine, could be due to naming convention.
For instance, instead of using C#6, the library might expect C#6 or C6. This is a common issue as there is no strict standard for naming sharps and flats in MIDI libraries and sound fonts. Here's how you can troubleshoot and fix this. Check the naming convention for sharps. Look at the documentation or the actual file names in the sound font to see how sharp notes are named. They might use a different character or format. Update your notes array. Once you know the correct format for sharps, update your notes array to match. For example, if the sound font uses Cs for C#, your array should be C6, F6 as 5.
Should I just try it manually? What are the other options? How do I get this character? Yeah, it's an actual thing. So would one of them play? Have to uncomment that, save, to rerun this. No, none of them plays. Okay, let's see.
Load all variants. As a workaround, you could attempt to load all common variants of each sharp note when initializing your piano. This would cover whichever naming convention the sound font uses. Here's an example of how you might adjust the load piano function to load common sharp note variants.
Yeah, but the other ones do not work. Is that case sensitive?
In this function, both the standard and alternative sharp note names are added to the notes to load array for each octave, ensuring that whichever naming convention the sound font uses for sharp notes, those notes are loaded.
Okay, but they don't actually work. sure there's much point in loading them. Oops, case sensitive or something. It's these little things get me stuck forever. Oh, this still don't work. How do I actually check?
Instead of using node names, you can use MIDI node numbers. MIDI node numbers are a standardized way to refer to musical notes, independent of naming conventions for sharps and flats. Each node on a keyboard is assigned a unique MIDI node number. For example, middle C, C4, is 60, C sharp 4, DB4 is 61, and so on. You can modify your code to use MIDI node numbers, which will bypass the issue of naming conventions entirely. Here's an example. Convert node names to MIDI numbers. First, convert your node names to MIDI node numbers. There are many online tools and tables for this, or you can write a function to do the conversion based on the piano's layout.
Okay, so I should just replace them with numbers, but how do I know which number is which?
Play using MIDI numbers. Modify the play sequence function to play notes using MIDI numbers instead of node names. Here's a simple example of how to modify your play sequence function. In this version, MIDI numbers is an array of MIDI node numbers. You will need to update your code where you define the notes to play to use MIDI numbers instead of node names. Using MIDI node numbers should resolve the issue with different naming conventions for sharps and flats, as MIDI numbers are universal standard.
At this stage, I'm happy to try anything. But essentially, problem is that these notes will play okay. All the other notes, so let's select channel 7 for example, should already start playing the notes. But still skipping ones that should be played okay. There's still something else going on. Seem to be two separate bugs. Yeah, kind of spent already 2 streams on this and still not able to solve this problem. The piano, so we're loading a grand piano, it's working okay, as you can hear. Then there is a function translating this EEG signal into those musical notes. So when you scroll through it, it should play the notes. It's playing them okay. Should be able to fix this. And what is it? We left with 7 minutes, 6 minutes to this stream. There seem to be 2 separate problems, because this skipping business is coming from a different part of the code. There's this play sequence. Okay, let's go with this suggestion. I don't have anything better. Play sequence. Is this complete? Let's close this for a sec. Yeah, we surely have to modify something else. We need to modify the backend as well for this to work. So this bit is done in the backend, isn't it? Is it? We haven't shared the Python code yet. We have time to do it now. Yes, we have MIDI numbers instead of nodes, but this nodes generated by the backend. We'll have to change quite a bit.
Modify the play sequence function to accept an array of MIDI numbers. Here's an example based on the previous version of the function. When you want to play a sequence of notes, use their MIDI numbers. For example, if you haven't already, ensure that your load piano function loads a full range of notes. Since you're now using MIDI numbers, we want to make sure all possible notes are available.
Okay, we'll just go with this, but that's not it. We need to modify the backend as well. Let's start from the bottom. And I don't think from memory we haven't shared the Python code yet. So in load piano, we just load all the nodes, so we don't need those names anymore, supposedly. So we can replace all that. Then replace sequence. Have the MIDI numbers. And let's put this. Let's also do format document. Right, now we need to change the place sequence function. Is this the complete function? Seems to be. app is not currently running. You have to start it again. Okay, so it's playing 4 notes. Question is, what will it do when we move the EEG scroller? Okay, it's actually working, surprisingly, without changing the backend. It's actually quite, let's try a window of, say, 30 seconds. Okay, just playing the same thing over and over again, isn't it? That's not good. I was getting happy too early. That's essentially just playing these 4 notes over and over, which is not cool. Yeah, now it won't play anything at all. When I scroll the file. Right, well, because we need to change the backend. So I have to update. We need to update this. This is the one that's actually generating the nodes. Yeah, that's general stuff. We'll just let it generate the general description.
Your Flask app, app.py, is set up to serve a web application that processes EEG data and converts it into musical notes. It has 3 main components. Serving the main page, the root serves an index, HTML page. EEG data endpoint, the get EEG data root fetches EEG data based on the provided start, count, and channel parameters. It uses the load_data function to read from a specified data file. EEG to music conversion endpoint, the convert EEG to music root takes EEG data and converts it into musical notes. This conversion process involves scaling EEG frequencies and mapping them to musical notes using linear interpolation. Potential updates or enhancements, error handling and logging. Improve error handling and logging for better debugging and maintenance. It's good to log errors, but also to provide meaningful feedback to the client in case of failure.
Yeah, let's stop reading that because that's generic stuff. The last response was too generic. We updated the JavaScript to use MIDI numbers instead of nodes. Do we need to update the back end to produce numbers, MIDI numbers, instead of nodes as well? Yep. Yeah, it is a significant change, isn't it?
Updating the JavaScript to use MIDI numbers instead of node names is a significant change that affects how your application interprets and handles musical data. If you have made this change on the client side, JavaScript, it's a good idea to reflect this change in the backend, Python, as well for consistency and to ensure smooth data flow between the front end and back end of your application. Here's how you can approach this. In your convert EEG to music root, where you currently convert EEG data to musical notes, you would now convert it to MIDI numbers instead. The process will involve 2 main steps. Mapping frequencies to MIDI numbers. Instead of mapping EEG frequencies to node names, you map them to MIDI numbers. The MIDI number for a given frequency can be calculated using a formula that relates frequency to MIDI numbers. Return MIDI numbers. The endpoint should now return an array of MIDI numbers instead of node names. Here's an example of how you can modify the conversion process in your Python code.
Okay, yeah, so we need to change the backend, which was kind of to be expected. Should we do it now?
Since you have already updated the JavaScript to work with MIDI numbers, ensure that it correctly handles the data received from the backend. The JavaScript should expect an array of MIDI numbers from the API and use them directly for playing music. After these changes, it's important to thoroughly test your application to ensure that both the front end and back end are in sync and that the conversion from EEG data to MIDI numbers and then to music playback is working as intended.
If it can just can you regenerate the whole working Python code with the necessary updates? Yep. So we have this extra function. There's a lot of magic numbers, a couple of magic numbers in it. It's supposed to convert MIDI frequency to MIDI. It's not good enough. Wait, where's a conversion? Yeah, convert EEG. Previous code.
Certainly. I'll integrate the changes for converting EEG data to MIDI numbers into the existing Python code for your Flask application. The updated script will include the functionality to handle EEG data and convert it into MIDI numbers, which will then be sent to the front end.
Okay, so we're still using interpolation. Just trying to make sure there's no any placeholders. Convert EEG to music. And it's the same code. Okay, there's a placeholder there. There's this range and scaling the MIDI. Should have been doing this already. It probably wasn't doing it correctly. Converting the frequency, didn't we already have that code? No, that should be okay. And this is a Flask application, right? Let's pop this one in, try integrating ourselves.
EEG data endpoint, get EEG data. This endpoint remains unchanged and continues to serve EEG data based on the requested parameters. EEG to MIDI conversion, convert EEG to music. This endpoint now uses the scale _EEG _MIDI function to convert EEG frequencies to MIDI numbers. It returns these MIDI numbers in response. Data scaling function, scale _EEG _MIDI. This function takes EEG frequencies, scales them to a specified range of MIDI numbers, and returns the scaled values. You can adjust the MIDI range as needed. Loading EEG data, load _data. This function should be implemented with your logic for loading EEG data from a file or other data source. Please make sure to replace the placeholder comments and functions with your actual data loading and processing logic. Additionally, test the application thoroughly to ensure that the conversions and data flows work as expected.
That's the regular test. When we scroll through the EEG, nothing. So piano was loaded with all the notes. Still thinking about it, isn't it? Was there something wrong? Let's just reload this quickly. No, piano's loading quickly. It's working okay. Let's make the window size 10. Any other placeholders or something? Scaled frequencies. Return MIDI numbers. Can't hear anything. Ah, come on, GPT-4, fix this for me. Need to start troubleshooting again. Just wondering. These nodes. Stand out play sequence. Well, that's the function. Let's say MIDI. It's the button play MIDI. However, nothing is played when scrolling through EEG. Scroll bar is moved. Yeah, that's right. Thank you, GitHub Co-pilot. Okay, I'm not sure how much progress we made today, if any. Might just continue this next time.
It appears that your JavaScript code is structured to handle EEG data visualization and music generation, but there's an issue with the play sequence function not being triggered when the scroll bar is moved. To resolve this, you need to ensure that play sequence is called with the correct MIDI numbers whenever the scroll bar is adjusted. Let's make some adjustments to your code to ensure this happens. Correct data handling in convert EEG to music function. Ensure that the data received from the convert EEG to music endpoint is correctly processed. It looks like you're expecting data. Notes: the base